can be used to play tones. So yeah, let's have a look at the code first. This example program can be found in the examples music player directory when you check out the EmbedVM source code from Subversion. The file firmware.cc contains the actual firmware. So we have one of these EmbedVM S structs here. It's just a global variable. And we have the virtual machine memory. And in this case, we simply initialize the virtual machine memory with the precompiled bytecode program. In a real-world application, you'd probably transfer the virtual machine code from somewhere outside, because the whole reason to have something like a virtual machine is that you can change easily what the virtual machine does at runtime. So the actual tone function, here it is, is implemented using this call user callback thing. It has 3 arguments. The first argument is the frequency, the second argument is the on period in milliseconds, and the third argument is the off period in milliseconds. The whole idea to provide an on and off period time here is that the actual firmware can buffer up to a small number of tones, and the virtual machine runs asynchronously to the actual music. So the fact that the virtual machine is pretty slow doesn't affect the timing of the music when the music has some fast parts or something like that. We also have VM read and the VM write function here. Both are pretty straightforward because I just have a normal memory region dedicated as virtual machine memory in this example. And the main program that you can see here has this main loop, and most of this main loop just handles the audio output and sees if it's time to change the frequency that is played on the buzzer and stuff like that. But the actual call to the virtual machine is also part of the main loop. Here we see this EmbedVM exec. This will execute exactly one virtual machine instruction. And we see that this is only done when the instruction pointer is not on the FFFF location, and there is still free space in this tone input buffer. So when this input buffer is full, the embedded virtual machine is suspended until more tones have been played, and so some additional free space has been created in this tone input buffer. Up here we initialize the virtual machine struct, and one thing we do is we set this instruction pointer to the FFFF location. So usually this EmbedVM exec function is not called inside the main loop, but then we have this EmbedVM interrupt here, and this creates the function call to the main function inside the virtual machine. So what does the virtual machine code look like? Here it is. Actually, this is auto-generated code from a MIDI file, but you can see it looks pretty C-like, probably a little bit JavaScript-like. A function keyword here, local variables declared using a local keyword. So it's a mix of various languages you might know already, and it's basically C-like. All variables are integers. There is support for integers arrays, as you can see here, but there is no support for structs or something you like inside EmbedVM. So let's run the compiler on this virtual machine program. I've built the compiler before, so we can simply start it here. This compiler generates a whole bunch of output files. There are stuff like an abstract syntax tree dump and other debug stuff. You're usually not interested in these files. There is a .bin file. It's just a binary representation of the program. It's the actual bytecode, and you can see this whole program is just 199 bytes virtual machine code. So it the compiler creates really compact virtual machine code. This was one of the design goals of the whole thing. And there is also a .hdr file, and this one can be used to use the generated virtual machine bytecode directly in a C program. It's bunch of C defined statements, and you see things like the address of the main function and the initializer for a character array with the SRAM data. That kind of stuff. And in this example, I've actually used this output file to load the virtual machine code into my firmware. So let's run it. I have my Arduino here, and I wired up the speaker to it, and when I press the reset button, the virtual machine will start executing the virtual machine code, and the virtual machine code will send tone commands to the firmware, and the firmware will actually play the melody. So let's give it a go. Finally, I'd like to talk about the role EmbedVM plays in the MetaLab project for the Hackerspace Challenge 2011. We created a device called EduBuzzer that can be used for a wide range of applications. In all these applications there is a PC program, and this PC program talks to the device. However, for some applications it was desired that part of the program logic runs directly on the devices. So we needed a way to easily reprogram the devices whenever we switch application. But it was important for us that the user or application programmer could never accidentally brick his or her device. So we created this virtual machine as an abstraction layer between the actual program logic and the low-level hardware interfaces. I hope you find the project at least a bit interesting. If you want more information, I will add the link to the project website to the description of this video. Bye!